welcome to today's class. My name is Afolabi. Afolashade. I am your facilitator for today's course, which is FSC 105. The course title is Introduction to Physics, and the topic we are considering today is physical quantities. In today's lesson, you will learn how physical quantities are categorized, and by the end of the lesson, you should be able to identify some familiar physical quantities and define fundamental and derived units. A physical quantity is any number or set of numbers used for a quantitative description of a physical phenomenon. For example, we have two kinds of physical quantities. There are two kinds of physical quantities. We have the fundamental quantities and the derived quantities. The fundamental quantities includes mass. We have mass. So we have length. And the third one, we have time. So when we are talking about fundamental quantities or basic quantities, we have mass, we have length, and we have time. The above quantities are noted for the study of mechanics. All these three, we'll be using them later in their studies in mechanics. Other basic quantities or derived quantities are current, temperature, intensity, and so on and so forth. Let us look at the derived quantities. Derived quantities are defined through the fundamental or what we call the basic quantities. The derived quantities are physical quantities that are obtained by simple combination of two or more fundamental quantities or basic quantities. Their corresponding units are called derived units. They are expressed algebraically in terms of basic units by means of mathematical symbols of multiplication or division. This includes, we have area, we have derived units. One, we have area. Two, volume. Three, we have force. Four, we have pressure. It goes on and on like that. I have said earlier, I said any unit that has a combination of two or more of the fundamental units is called a derived unit. Let me cite examples of how derived units are formed. For instance, we have the basic or fundamental units of length. When we have two combinations, for instance, we have to calculate the area of a place. The area of a place, the area is length times breadth. And when we have length and breadth, it means we have double length, which is length times length, which gives us length squared. That is the multiplication of length and length will give us length squared, which is, in other words, it is length and breadth. Then coming here, we call this one a derived unit of our area. When you look at here, the fundamental of the basic unit, we have length there as our number 2. So when we have 2 of length, it will give us an area, which it means that when we have two combination of this, it gives us the derived unit of area, which goes along with the definition that we said that when we have two or more combinations of fundamental units, it will give us a derived unit. Another example is, let us take a look at volume. Volume. It is length times length times length in 3 places. When you have this, we have length cubed. It means 3 combinations of length here as the fundamental or basic unit will give us a derived unit which is called volume. Another example of derived unit is density. Density. And when we talk about density, density of an object is also a derived quantity. Why? The density of matter is expressed as the mass of the body per volume. That is, density is equal to mass of substance of a substance. The mass of a substance per the volume of the substance. The mass of a substance per the volume of the substance. So when we are talking of the mass of the substance, it means we have, whether it is measured in grams or it is measured in kg, which is the kilogram, we have the mass over the volume of the substance. And don't forget, also the volume is length in 3 places, which is length cube. We have length as in 3 places, which is length cube. So now we can see that derived units are combinations of 2 or more fundamental units. The density, the mass of the substance, is a fundamental unit, which is the mass, which appears here. Then we have the length also, which is represented here. It's also a fundamental unit. So when we have 2 or more combinations of these fundamental units, we have the derived unit. I'm going to leave you with this assignment, and before we conclude the class, let's quickly go over what I have taught you. We defined the fundamental units and also the derived units, and we said we have physical quantities. The physical quantities can be categorized into either fundamental units, which is also called the basic units, or derived units. I have given you examples of fundamental units. At least we have the 3 basic ones, which is the mass, the length, and also the time. And I've given you examples of derived units, which are area, volume, force, pressure, and density. These are those that are commonly used in our day-to-day activities. Before I end today's lesson, let me leave you with this assignment. List all the derived quantities that have not been mentioned in our today's lesson. However, you may have questions or you need more clarifications. Kindly contact me on the email address being scrolled on your screen. I wish you all the best. Bye for now.